So in this problem, I've intentionally written it in a way that might seem a little confusing at first. We want to convert 9.8 meters per second, a rate, something moving, to miles per hour. And notice I wrote miles per hour out in words as opposed to symbols. The reason why is you're going to see units given to you in many different formats. Sometimes it'll be in the proper abbreviation form. Other times it'll actually be written out. When I have meters per second, the -1 exponent is the same as what is used in math. So x to the -1 is 1 over x. As you're taking introductory chemistry, go back through your notes of algebra if you're a little weak on that subject, because every calculation we do is inherently going to be touching on algebra one way or another. Multiplying, dividing, exponents, and so forth. So you put yourself at a disadvantage if you're a little cloudy on that. So miles per hour means that we have a unit that is miles, and I'll abbreviate it MI, hour to the -1. And some textbooks do this, some don't. You notice there's no little dot or anything like that between the units. It's understood if you have two units, two variables, if you will, that if they're just next to each other, that you're multiplying. Sometimes you'll see a dot or parentheses and so forth. But in this case, miles hour to the -1, miles per hour. So how do we do this? Again, whether it's your textbook or the handout that I gave you, you're going to need to know some material. The only thing for my course that I had the expectation that you'll memorize, that you'll know like that, are the units of kilo through milli, the metric system. Something like meters to miles, no. That I'll give you. So let's go ahead and set it up. Again, dimensional analysis. We look for what we're given, which is 9.8 meters per second. Let's just write that out explicitly. Meters. And now that we're dealing with 2 units, this is where things get a little more confusing. So when I draw this grid, give myself plenty of room. Instead of writing it as meters seconds to the -1, I move the seconds below, which is the equivalent of doing that. And you'll see why, because it just makes it easier. You could leave it in on top, but then you have to be very careful of keeping track of the conversions. So now we want to convert this to miles per hour. And I'll go ahead and just kind of write it that way, so that way when I'm talking about it, it stays more fresh in your mind of where we're headed. So miles per hour is our goal, and we got meters per second. So how do we get there? Well, we're going to have to do 2 sets of conversions. We're going to have to do a conversion for length, which is meters to miles, and we're going to have to do another conversion for seconds, seconds to hours. Be systematic. Pick one, go with it, make the changes, and then worry about the other. If you try and mush them all into one calculation, that's where things go bad. So just to be different, I'm going to start with seconds. So I want to go from seconds, per second, second to the -1, to hours to the -1. So how do I do that? Well, I've got seconds. I know 60 seconds is 1 minute. Seconds cancel. but now I'm left in units of minutes. And I actually gave you these conversions. Time conversions are things we inherently know, but just to be explicit, I wrote it out. Well, I don't want meters per minute, I want meters per hour. So, 60 minutes is 1 hour. Minutes cancel, and now I'm in the unit of hour. Many of you are going to be smart enough that you can say, well, 60 times 60 is 3,600 seconds. Can't I just put that in? And the answer is yes, if you know how to do that. If you don't worry about it, because the math will all work out at the end anyway. So look what we've accomplished in basically a very small amount of time. We've gone from meters per second to meters per hour. Oh, excuse me. HR. So again, with English units, by the way, one of the reasons why I wrote out miles is you typically, their abbreviations can be a little bit more obscure than the metric system. The metric system is very good as far as being systematic, whereas the English system is not systematic at all, which is why everybody except the United States uses the metric system. So, meters. We want miles. We have meters per hour. So now what we need to do is look at our conversion factor and see what we have. Well, we have mile, but it's not converted to meters directly. So what we have is kilometers. Let me write this off to the side, just so you know what my thought process is. Off to the side, and again, I was about to do this, which is a bad habit. I was about to do a conversion in my head and then just slap it on the board, which, if I'm trying to explain it to you, wouldn't be very beneficial. So, on my conversion sheet, I have 1 mile gives me 1.609 kilometers. But I got meters, I don't have kilometers. So what we need to do is we need to convert, oh, sorry, that's the automatic lighting in here going on and off. What we have is kilometers. So we need a conversion between meters and kilometers. And again, this is where the metric system comes into play. You should know that 1,000 meters is going to be 1 kilometer. And what I was saying, that as I looked at this, I was about to do that conversion in my head and then just slap it up on the board. But you don't have to do it that way. Again, with dimensional analysis, you want to be as methodical as possible. Every single step you want written out explicitly, because if you skip a step, you're going to make a mistake. Sooner or later, it'll come back and bite you. So, meters cancel. Now we have units of kilometers. Well, we're still trying to get to miles, right? Don't forget what we're doing. But my conversion tells me that 1.609 kilometers is 1 mile. Kilometers cancel. I have miles. Now I'm done. Typically, you notice how I drew this grid out. It's longer than I needed. And that's just because I was being safe rather than being sorry as far as just spacing. But it doesn't mean anything. Now let's look at what we did. 1, 2, 3, 4 conversions in a row. We're going to multiply, we're going to divide, and get our answer. But before we pick up our calculator, meters have canceled, right? Kilometers have canceled. I have the unit of mile, and seconds cancel, minutes cancel, hour is left over. Miles per hour. So I'm perfectly fine now. I can do the calculation. If I inverted something, if I tried to do something in my head and I ended up getting 1,000 meters over 1 kilometer, the units wouldn't cancel, and that would tell me I've made a mistake. Be systematic. Don't ever skip a step just because you can do it in your head. Because if you do that, you'll get out of sequence when you start using this grid. And again, 1, 2, 3, 4 conversions. We'll have problems that require more than 4 conversions, 5, 6, and possibly even beyond that. So be systematic. Now, we just do the math. If I don't break my calculator into a million pieces. So 9.8 times 60 times 60 divided by 1,000 divided by 1.609, and that gives me 21.9267. Well, 9.8, right? That's what we were given. So the number of significant figures that our final answer is going to have is going to be 2. By the way, I pluralized it. You don't have to do that. It just should be mile per hour, not miles per hour. And again, that's why the whole thing with English units, that's why it's better to use metric. So 9.8 meters per second is 22 miles per hour. You might be saying, well, I know about significant figures, and if there's no decimal point behind this, why is this 2 significant figures and not 1? Well, if you go back in your textbook, when you have exact counting definitions, in other words, there are exactly 60 seconds in 1 minute, there's no ambiguity there. This doesn't have 1 or 2 significant figures, it actually has an infinite number of significant figures. So it doesn't change our value at all. So in other words, 9.8 is actually what we've measured. That's what defines our number of significant figures, not our conversion factors. This one potentially could if we didn't have it out to 4 significant figures. But 60 seconds, 60 minutes, 1,000 meters, those are all exact definitions. So they're going to have no impact whatsoever on our final answer. So again, meters per second, miles per hour, we've done the conversion, and everything looks good. The worst you can do if you set it up this way is to make a small mistake when you type it in your calculator. And again, I multiply, then divide. It doesn't matter the order that you do it. I just like to be systematic, work across, and then work down. But if I took 9.8 divided by 1, times it by 60, divided by 1,000, and so forth, it would be helter-skelter of me moving around the table, but mathematically, it would make no difference. Just be systematic. That's the best advice I can give you in any dimensional analysis problem. If you're basically the turtle in the race of just setting things up slowly and systematically, you'll win. So.